This is lecture 5. So basically, um, continuation of the magnitude and unit vector. So what we have learned is that this is the notation for the magnitude of a vector. This line here, which is equal to square root of x squared plus y squared for um, two-dimensional. Okay. For three-dimensional, we have said that this is the symbol for the magnitude and this is the formula. And then we also have learned the unit vector. And when we say unit vector, the vector which is of the same direction, but then the length is only 1. So a unit vector is a vector of magnitude 1. And how to do that is this is the formula, wherein this is, for example, what we have said is vector A is xyz and 1 over the length of the A, which is x squared plus y squared plus z squared. And we have what we know as parallel vectors. What do you mean by parallel vectors? So let's say that this is my vector A, and then I have another vector which is 2 times of its length, 2A. So these vectors are parallel with each other. So let's say that this is vector P. Okay, vector P is equal to 2 times of vector A. So therefore we can say that this vector P is parallel to vector A. Let's try to have another example. So let's say that I have a vector Q and my vector Q is 1, 2, 3. I have a vector P which is equal to 3 times of vector Q. So which is equal to 3 times of 1, 2, 3, which is equal to 3, 6, 9. So we can say that the vector P is parallel to vector Q because it says parallel vectors must be scalar multiples. What do you mean by that, scalar multiples? So as you can see, the 2 here is a scalar, okay, and it's being multiplied the A, so that's what's called scalar multiplication. Okay, so what about in here? The scalar is 3. Now, can the scalar be a negative number? Yes, it can. So for example, I have here this vector, and let's say that vector, the white one, is vector A but negative. So meaning it is the same length with A but of opposite direction. Okay, so again, negative A is opposite of vector A. All right. For example, you have negative 2A. So let's say negative 2A. So negative 2 is a scalar number. So meaning to say the scalar can be positive number, can be negative number, it can be decimal, let's say 0.2 vector A, or it can be fraction, 3/4 of vector A. Alright, it can also be radical, the square root of 3 of vector A. Okay, so that's what you mean by parallel vectors. They are vectors which have the same direction. Let's try to look at this one. Find the magnitude of this vector. Again, it's very easy. That is 3 squared plus 4 squared plus 6 squared, and thus simply simplify. Hence, write down the unit vector in this direction of, so basically whatever your answer, so that's going to be 3, 4, 6, okay? And then 1 over whatever is this one. 9 plus 16 plus 36. Which is what? 36 plus 16, 52 plus 9, 61. So basically, the answer now is 3, 4, 6, 1 over the square root of 61. And again, this can be written as this if you want. They're just the same. Or they can be written as a unit vector. So for example, vector notation. Let's say for example, 3 is square root of 61i plus 4 is square root of 61j plus 6 over square root of 61k. Alright? Next, find the value of k for which the vectors are parallel. Again, they are parallel. Two vectors are parallel. Okay, parallel if you can express the other vector as the product of the other. Okay, what does it mean? Let's try to look at the question. We have 2, negative 1, 6 and 8, negative 4, k. So basically, as you can see, if you will multiply this one by 4, you will get this one, right? 4 times 2 is 8. 4 times negative 1 is negative 4, which is that one. So therefore, k is equal to 4 times 6, which is equal to 24. Okay? So, because we have written 8 negative 4k as the scalar product of the given vector times 4, so therefore, these two vectors are parallel. They have the same direction. Okay? Don't forget that's how to show that they are actually parallel. Find the value of t for which the vectors are equal. Vectors are equal if they have the same xyz. So basically, you're looking for the t wherein they're equal, right? So meaning 5 plus t is equal to 3. So therefore the t here in this one, the t there is equal to negative 2. In the other one, 3 minus 3t is equal to 9. Negative 3t is equal to 6. Then t is equal to negative 2. So therefore, these two vectors are equal with each other. Okay? Because the x here and the x here are equal. The y and the y's are equal. The z and the z's are equal. Let's try to look at this other example here. Find the value. I think this is just a little bit easier for you. Okay? These are equal vectors, so we can just skip that one. Okay, this one. The points a, negative 1, 2, 3, a, b, c, d they form a parallelogram. So this is basically the same as my example a while ago. So that is a, that is b, that is c, that is d. And then you are looking for the coordinates of c because the c is x, y, z, and it is not given. And let's see that this is your origin here. Alright? So basically the coordinate of c, so meaning from O, you're gonna go to C so that you would be able to get the coordinate of your C. So that is that vector OC. And how shall we go to that vector OC? So basically, either you can go from OA, you know what guys, you can just look at and follow exactly the examples from the previous video. But basically from O, you're gonna go to A, then go to B, then you go to BC. So this one, AB, then you go to BC. However, BC is parallel to AD. So therefore, we can just say plus AD because they're parallel. Okay? And then you can just find what is AB, what is AD. So basically, just follow the same process from the last video. Let's try to answer letter B. So letter B says find a unit vector in the direction of AD. So let's try to find the AD. Okay, AD is equal to OD minus OA. Okay, which is equal to negative 2, 4, 5. Negative 2, 4, 5 minus OA, which is negative 1, 0, 3. Alright, so therefore AD now is equal to negative 3, 4, 2. So you're looking for a unit vector in the direction of AD. So again, so the step number 1 is to find the vector itself. So that is step number 1. You find the AD. Okay, step 1, find the AD. Step 2, find the length of AD. Find the length, and that is equal to square root of negative 3 squared plus 4 squared plus 2 squared. Okay, which is equal to square root of 9 plus 16 plus 4, square root of 29. And the step 3, you write it as 1 over the length of AD times the vector AD itself. So this is your unit vector. Again, this is the symbol for unit vector. Unit vector. AD hot. Like, it's called AD hot like that. Okay? So therefore, the final answer now is 1 over square root of 29. And then you copy this one, negative 3, 4, 2. Alright, so hope you learned something. Please remember everything that we have just discussed so that you would be able to get better score in your Cambridge. Thank you.